sure you can all see the screen in front of you. I should say learning from text. Well, I'm Michael Dowling. I'm a professor of finance in Dublin City University. I've just moved back to Ireland from France. I spent 5 years in Rennes, close to where Nicholas was born and reared. And while I was there, I ran a research center on the impact of AI in business, and a big part of what we did there and the training and the research was about making business people familiar with Python. I'd say I'm more a user of Python. I use it to solve specific problems rather than an expert. I'm definitely not an expert, but I use it to solve quite a few research problems. And in finance, we have a pretty big problem that we use numbers too much, and there's so much knowledge in text. So that's kind of what led to the topic of today, and a lot of the research that I'd personally do now. So it's about how can we take a lot of text documents you don't necessarily know much about, and how can we use Python to extract knowledge from those texts, to extract some form of understanding. And what I've done is I took some cycling articles from the Irish Times. The idea popped into my head because the Irish Times always seems to be complaining about cyclists, getting in the way of the SUVs of their target reader base. So I took the 1,000 most recent cycling articles in the Irish Times. The articles have to have cycling or cyclist in the title, or bicycle. And these are articles that run from about the year 2000 up until last week, pretty much. It's quite a small data set. About 1,000 documents is about the minimum number of documents that you would want for this type of study. Ideally, you'd have tens of thousands, but it's enough to kind of show the potential of this method. So I've included the code. It's up on GitHub at the GitHub address there, and what I'm going to show is, well, how do we go from these raw material that we get from the Irish Times all the way up to quite a deep understanding of these articles? What are the main topics of cycling that are covered in the Irish Times, for example? And I suppose then for you, I suppose what you might be able to see is some of the ways in which this could be applicable for you. I personally work on research projects with company annual reports doing this type of topic modeling, with academic research articles where we try to look at topics across these, with news articles. And so it's a great technique for getting knowledge out of text and out of huge amounts of text. So we start with the basic Python's basic toolkit for natural language processing for working with text, NLTK. We also have a package, Spacy. Spacy is a pretty great package if you're not familiar with it. It essentially can read, comprehend sentences and look at the words and go, well, this word is a noun, this word is a verb, this word is an adjective. Very high accuracy. And then for the specific topic modeling, there's a package called GenSim, which is very good. Up until GenSim, topic modeling, which has been around for about 20 years. And I'll explain it a bit later, but GenSim was topic modeling could only be done really through OR. because it's a more academic program. So we're working with GenSim and with PyLDA-Viz, which is a way of visualizing our topics. A bit of the software, and this is why I couldn't upload this to my binder, a bit of the software for doing very good topic modeling needs to rest on your computer. It's a Java package on the computer. But there's instructions there on how to get that package. So our data. Here we go. We have title, abstract, the publication, the year, the date, where it was in the paper, and I got this from a database called ProQuest. If you're a graduate of an Irish university, you can get a visiting card, and you can use their electronic data sets. And one of the data sets that all Irish universities have is ProQuest, which gives you electronic access to news. But this actual data set is uploaded on GitHub. So that's our starting point. So because of the restriction of the data set is 1,000 articles, and 719 of these have abstracts. And what these are is these are summaries of the articles. I chose these rather than the full article because a full article kind of meanders a bit. In a full article, you'll have examples and you'll have side notes, etc. Whereas the summary of an article gives you the core parts of the article. We ideally want to work with text that's not too short, like tweets are hard to work with for topic modeling. It's not too short or it isn't too long either. So we have 719 workable articles in our data set. So we're just going to condense the title and the abstract because they're both text. So we may as well use all the text we have. And the average summary of an article is 111 words. And it's from this that we're going to do the topic modeling. So here's an example of a summary. And it's I think it's quite a great article because it epitomizes maybe everything that's wrong with cycling in Ireland. That a bus driver working for Bus Éireann, the Irish state bus company, a bus driver, he's hit a cyclist, I think it was, with a bus, and then the cyclist was taking pictures, and then the bus driver got off the bus and beat up the cyclist, and then the cyclist brought the bus driver to court, and Bus Éireann, the state bus company, defended their driver on the claim, well, on whatever grounds they chose. But you would think that maybe that's a court case you wouldn't want to argue really, that your coach drivers should be allowed to beat up random cyclists. But here's an example of those types of stories that we have. So we're going to now pre-process this. So I have some examples here, mainly using regex. We're going to get rid of special characters, of numbers, of little features to do with the text. Multiple spaces instead of single spaces, very common with text. Little prefixes, all that type of just basic cleaning up. And then we turn it into what's known as a bag of words, which is a list of all the words that are remaining after we do that processing. So this is the same article of the bus driver beating up the cyclist that we were just looking at. But you see now the award, the cyclist was awarded €15,000, but that 15,000 is gone. The punctuation is gone. It's just individual words contained in a list. But there's still a lot of words there that don't look too useful. For, by, that, he, had, specific names like Judge Jacqueline Linan. So we want to now process this to reduce down these words so that we're not interfered with by these words in our later analysis. Now, I can't actually see if anyone's asking any questions. So if you are asking any questions, I'm not.
I'm monitoring that, and I will let you know. All right.
Yeah. Great. Yeah, because so I'll just assume it's all going grand, unless I hear a.
But it's fair. So there is a question option that everyone should have in their console here, and feel free to add them. And when you feel it's the right moment to interact, we can see what's there at that stage. That's no problem.
Perfect. Yeah, just shout them out whenever. So we had stopped at a point where we had taken the basic text and turned it into individual words held in a list. Now I see there's a few participants with hands up, which might mean there's kind of some core questions that we can answer at this stage before we make it more complicated. Like, say, I see Raphael Lamaz has a hand up there.
Oh, is that the first attendant that forgot to lower their hands?
I don't know. I can just continue, but
we have Connor, only one. Yeah, please write your question in
the
Q&A panel.
I'll continue in the meantime then. Grand. So we have that basic structure of clean text. Now we want to turn it into a matrix, which is suitable for testing, for doing things to. We can do loads of things to this matrix. We could do up word clouds, showing prominent text, because essentially what the matrix is a count of terms, words that are used across all documents. So essentially there will be a number of documents multiplied by the number of terms style matrix. And there will be a count of the use of terms. So for this particular first document, we see there's at least 2 uses of for. So the word for will be one of the rows, and it will have a count of 2 or 3 or however many uses of for there are in this matrix. And that's for all terms and all documents. To get rid of not very useful terms, what we do is we first of all remove stop words, and then we lemmatize as a preferred process. Stop words is getting rid of those kind of link words that aren't particularly good, things like for, and, of, de. And lemmatization is where we use the package spaCy to comprehend the sentences and only to keep certain features of each sentence. So we might, for example, only keep nouns, adjectives, verbs, adverbs. We also add some extra words that we want to exclude, which are unique to our database. So even though cycle might not be a common word in general, across in documents, it's a very common word in our data set. So we want to remove it because there's no explanatory power that we can really get from that. So I've added a few extra stop words here. And here is the implementation of those little programs. And what I've done is I've kept only nouns in that appear in each text, and removed all the stop words. The reason I only kept the nouns, that was a choice, but I was struggling to improve the the explainability of the model, and I came across a few papers saying you can improve the coherency of models by just keeping nouns. And so this is that same article that we started with of the bus driver beating up the cyclist, but this is all that now remains. So these are all interpreted by Spacey as nouns. But you'll see there's it's not perfect because it's a program, but it's pretty good. You see, for example, the word exchange is kept there, and it's viewed by Spacey as a noun, even though exchange is both a noun and a verb. Spacey has interpreted it as a noun, even though it's used in the article as a verb. So it's not perfect, but it's pretty good at keeping the important words. We also have a lot of words used across these abstracts. So we want to remove words that aren't used very often, remove words that aren't used in at least 5 documents. And this gives us a dictionary of 633 words remaining across all of our documents. So, topic modeling then. This was developed by a few people, including David Blay and Andrew Nye. Andrew Nye teaches that Stanford deep learning course on Coursera that a lot of people have at least tried to do. He recently released it in Python. I think he released it as a deep learning in Python course about 1 year ago now. I tried learning it over the last lockdown to fairly quick failure. So topic modeling.
Michael?
Yeah.
But it seems like a pivot point in your presentation here, where you're going to the. So we have a couple, 3 questions pending now. So Anne is asking, and I think hopefully it became evident, why did you remove the numbers from the original data set? Well, I figure you need to. This won't give you any topic. It's a value that is meaningless. It's 1,500 given to this man, but it's only 1 article in thousands. But you're teaching finance, so are you really getting rid of all the numbers?
Well, it's I mean the reason for choosing to remove the numbers is because we're eventually change it to a bag of words where there's no context kept in the order of words, and so numbers lose their meaning very quickly when you remove any context. So you would just have the number 15,000 floating around in a data set. So if we were keeping, say, the sentence, like the full sentence and its context meaning, then the number would be useful. The problem is if we're breaking it up into individual words. So thanks for that. And then I see there's a question from Jay here. I didn't get what we're trying to achieve. Find articles about cyclists involved in traffic incidents or something else. Yeah, it's essentially I picked a random data set. I was trying to think of something not to do with Corona, so something more positive. So I just picked cyclists because there's a lot of media coverage recently about a cycle route they're building in Sandy Fort or something, or Sandy Cove. So I just picked that as a topic, and the idea is not to try to answer anything, but is to just go, well, how does the Irish Times talk about cyclists? What are the ways? Do they mainly talk about cycle routes? Do they mainly talk about accidents, for example? So just to understand the conversation that the Irish Times has about cyclists. Now we could then bring this into a business context, and let's say you were looking at all the documentation of a company, and you wanted to run this type of exercise, it could be like, what are the main things that this company talks about? What are their main topics? One of the topics might be customer complaints. One of the topics might be research and development. Another might be HR related issues. So it's just using cycling as a way of understanding the subtopics. So yeah, and just to go back to, and then if you wanted, you could of course keep the numbers. There's no reason you'd have to take it out. So, but you've got a good point there, that if you kept it in a bigram or a trigram, you could keep the context. That's, yeah, definitely. I actually had a slide on bigrams, trigrams. I only show an example here of unigrams. But yeah, that would be a way in which you could keep numbers. You'd need to have the same numbers used though for it to be a term that's used frequently enough. And then Irina, so the tweets, I did say they were too short for topic modeling. They're not. They're difficult for topic modeling is the way I should have said it. As you look and say Google Scholar, there's a lot of research has been done of, well, how can we trust our topic models if we're using tweets? Or a lot of this research is done in China. I've forgotten the name of the Chinese version of Twitter, but Weibo, I think. How can we use Weibo for our topic modeling? So that there's ways around it. There's just it's just that you miss quite a lot of the context, so you don't have much to work with. I'd say between about 100 and 500 words is what I've read is quite a nice length to work with. If it's much longer, you maybe need to do a shortening exercise, and if it's too short, well, it's just difficult. But Glassdoor reviews, that's something I've actually seen for topic modeling. It's definitely something that can be done. Yeah. I don't know. I think will I move on now, because that was great to have the chance to do that.
Yeah, I think you've cleared the board. So
grand. Okay, so I've included a graph here. Though I often forget what all the bits of the graph mean, but topic modeling. Essentially, the idea is that the assumption of topic modeling is that when a writer is writing something, they choose words that reflect the topic that's in their head. So a cyclist, a journalist writing about football will choose football related words. So by observing those words, you can uncover the hidden topics within an article and across articles. And the way in which the most popular form of topic modeling does this, latent Dirichlet allocation, is it uses something called Dirichlet priors to estimate the distribution of words and therefore topics across documents. It's easier understood in practice, but we're trying to use the words to determine the topics, and that's different than to say keyword searching. Keyword searching, you don't have the same cluster and the interrelationship between all the words. With topic modeling, it's there's a lovely relationship across loads of words that then when you see all those top words that belong to a topic, you can imagine the topic a lot more obviously than you can with keyword or latent semantic allocation. So I'll just show you how it works. So we have so the big issue in topic modeling is that you are assuming across a set of documents that there are a number of topics, but you don't know how many topics. Once you have the right number of topics that you don't know, then the model will go ahead and do its thing. If you were to somehow know that that cycling articles fall into 10 different categories or topics, if you were to somehow know that, then you could set the topic model for 10 topics, and the model would very efficiently go and find those 10 topics. But we don't know this in advance. So what we do is we test a wide range. We test a number of topics. So we run the topic model for, say, for in my case, in this case, for 4 topics, and then we raise it by 2 each time. So we run the topic model for 4 topics, we get the answer, we run it again for 6 topics, for 8, 10, all the way up to 18 topics. That's in this particular iteration of the model. I've ran it on this data from between 2 and 50 topics. And the final model, I just checked this smaller group. And so we're running multiple models here. It takes a long time. The initial running of this model took about 6 hours. This version is a reduced version, but still took about 50 minutes. And so we check, we run the model, we let it do its expectation maximization thing for 4 topics, 6 topics, 8 topics, etc. We give it some starting parameters up here, which are how much importance to attach to learning, or random seeds, so that the data doesn't get stuck in some sort of local effect. That's a big issue with text, and it's the main issue that more complicated versions of topic model are trying to solve. And we run this. And I have run this, and I've extracted out, for this point, the coherence scores. Coherence scores, there's a few different types of coherence scores. Coherence scores are a way of statistically estimating that if an expert in an area was to look at a topic, of estimating, would they judge they make perfect sense. 1 would be topics making perfect sense. 0 would be topics making no sense. So you're looking for a score between 0 and 1. Anything over 0.8 is suspicious. Anything over 0.4 is good or okay. 0.5 is good. 0.6 very good. 0.7 great. These are approximations, but the coherence scores are statistical estimates, and we can't really get away from just needing to look at the topics and see what makes most sense. So this is a sorting of all the models, and it said that the model with 4 topics, a random seed 32, and an alpha, a learning aid of 0.1, has a coherence of 0.5. And that's the best model according to the coherence statistic. So that would be the first model we would look at and see if it makes sense. So I'm gonna show you.
You get your runtime on a Raspberry, a GPU, a mainframe, a laptop.
I've had to run it on the laptop because of the underlying Java program that I haven't been able to upload to Azure. And I was using Google Colab for the research. I was using a premium account there, but the issue was connecting to the Java package. So it's just a laptop, but it's a nice laptop. It's a new, powerful one that I bought knowing I'd be running a lot of data through it. And so but yeah, still it took quite a while. It's a famously CPU intensive process.
Yeah, so the question here I have in the stack is, any chance to leverage the GPU with those kind
Yeah,
of computations?
no, there is actually there's a big thing about GPU helping with this process, because I was using the Google Colab Professional Edition. I'd set up a US proxy to get to Professional Edition, and they gave access to a very nice GPU, and it definitely speeded up the process. But yeah, still slow enough though. For the particular model that I was trying to use Google Colab for with that nice GPU, it was about 800,000 news stories. So it was a substantially larger study. I think my laptop itself would have exploded. So yeah. Here, let me show you the results. So this is from 4 topics, and so what we have here is the 10 most popular terms that belong to this topic, etc. And we see that the topics make sense. Quite. So the first topic. So this, you see, the way you'd read this is city has about 0.5. That is articles with the word city in it have about a 5% chance of belonging to this topic. But city appears in quite a number of topics. All words can appear in all topics, just in different proportions. But when we look at the totality of these words, we see it's around public transport is what it seems to be. Bike to work scheme, city, cars, lane is probably cycle lane, transport. We look at the second topic, and it's around traffic accidents. We look at the third topic, and it's around professional cycling. And then the fourth topic seems to be around safety, and this is quite different to this. This seems to be court reporting, which is quite specialist journalists tend to report this, and they have their own vocabulary, whereas this is around driving safety. So essentially what the model has done is, yeah, it's given us 4 pretty decent topics that make a lot of sense. But I just wanted to explore it a bit more, because I felt these topics weren't great when I looked at some of the articles, and so I read down this list to see, well, is there an article? Is there a model with an okay coherence that has a lot more topics, and maybe and maybe there's something interesting there. Maybe extending it out to 8 topics might be good. I mean, any topic can have just the coherence is a statistical estimate of coherency. So it's not an absolute rule that you'd want to pick the top one. It's nice if you can pick the top one in terms of justifying it to other people. But when I looked at the 8 topics, I thought it gave a nice level of refinement in terms of really understanding what's going on. And so when we look at these topics, if we look here, professional cycling, at deaths and collision, at city, at urban transport. This one is quite interesting. Seems to be about commuting. issues such as the low female participation in cycling, getting into work, safety, ownership of bikes, things like bike locks, the tax scheme for availing of bikes, of a cycle to work scheme, all in there, and then something about cycle routes as well. So depending on what you want the topic model for, you might choose to sacrifice some of the coherence for a greater variety of things to talk about. And there's a way of kind of checking if your model is approximately okay, and that's through this PyLDA viz, which is a way of visualizing your topics. And so here is the one with 4 topics, and essentially the less these overlap, I mean, I'm simplifying, but the less these overlap, the better. So these are lovely and spread out. They're not overlapping with each other. So so when we were looking at the 4 topics, these are 4 good topics. They weren't 2 models trying to explain the other. And when we get to the 8 topics, we do see a little bit of overlap between 2 topics. But in general, they're all nicely spread out as well. And this spread is part of the way of statistically measuring coherence. So these seem like essentially decent articles. Now, and this is going to be my finishing point now, because we can now put these, we can now do some fun things with these topics. And this is where we can really kind of add a lot of value, because now we have the topics, but what do we want to do with them? So we can look at, we can, for example, put those topics back in our original data set. And that's what I've done here, going saying, what is the dominant topic for each news story? And we could then do something like this, which doesn't quite work because of the amount of, because of the low amount of news stories. But we see that over time, this purple topic is much more prominent, or in the later period compared to the earlier period, this purple topic. And that topic then is, this one about commuting. I have no idea why Cork is there, but so it's essentially it's become as it has become the national conversation. So it has been. So we see it as well in our topic modeling of something where we didn't know what the topics were. That it has identified this big rise in discussion around commuting, some of the hassles of commuting into work by bike. What we could do, and this is something I haven't done, is we could take each of these subtopics that are now attached to articles, and we could run sentiment analysis on each of those subtopics and go, well, is maybe the Irish Times, are they in general quite neutral about cycling, but that when it comes to say this cycling infrastructure, they might take away from the cars that they seem to appreciate so much. Is this where they start to introduce the negative sentiment? And so that's kind of me really really done now in terms of what I wanted to explain. And as I was kind of saying, and as I was kind of saying, I just use this as an example. But if we imagine this on a like looking through a set of corporate documents to understand where are we devoting our work time to, and seeing this huge proportion of our work discussion is around HR issues, we could use that to identify a problem in the maybe topics we're ignoring in the workplace. we could look at there's been quite a bit of work done looking at patents. So what they do with the patents is they go through patent announcements, topic modeling, trying to identify true novelty. And true novelty in a patent is a patent that doesn't fit into any existing topics. So it's an outlier compared to existing topics of innovation. So it seems quite endless, the possibility. So that's what I wanted to discuss. That's me done now. Are you there?
Well done. Yeah, we are still we're still around. Still many people around. So I'm not sure this. Yeah, this was covering. Oh no, we have more questions coming. See, they keep popping up. No, so blah, blah, blah. Yeah, so I can answer a few of them. So yeah, the initial data set was you got it from the university, right? A special subscription.
Yes, but I did check beforehand that particular data set, I've uploaded it on GitHub on the link. I can maybe paste that again. But I was checking how do people access these data sets, because of course everybody pays for these data sets. They're paid for by tax, but it seems you have to be a graduate of a university in order to be able to get into it. So that's what I was told. I didn't realize that. I don't know why they don't have more people in. Let me.
I'm closing question. I resent your GitHub link.
Perfect. I was just about to post it.
As well, if you don't mind, we'll place it as a comment of the event on meetup.com. So as a reference for
perfect
people, and say as a proof it has really happened. And so how many times did you run this tweaking? What if I should add more? I've played the modeling stuff like that, and I know the rabbit hole you can go into. It's okay, I'm going to tune my parameters here and there, and you mentioned 6 hours runtime. So I guess you do that, and then you go to bed, and you do it once a day. So what's the time?
Yeah.
The human time investment?
Yeah, it was quite a lot of the computer was doing all the work, not me. Yeah, once I'd set up the initial code, but it did take a while, because the big issue is actually quite. So there was a discussion I had in this slide that I eventually took out because I felt there was enough in there already, but it's around bigrams versus unigrams. So this was a study of unigrams, and once you get into bigrams, it gets very messy. So I've a PhD student who's hopefully not here, so he doesn't, but who spent well over a month for a particular study, reading through lists of bigrams, and it gets really individual. So what it means then with bigrams is it's not very replicable, because everyone can make different decisions. But yeah, literally it was well over a month, or at least he said it was well over a month. With confinement, we never know. We never know if anybody is working anymore. But he said it was well over a month to read through all these tens of thousands of bigrams, and but with unigrams, the issue is how many words to exclude, how many of the most popular words and how many of the least popular words, and that's where all the retesting comes in, because it has a huge impact on the solving of the model and how well it's able to solve.
On the outcome,
yeah.
Okay, I'm closing the questions. I'll Christophe or Christophe Alexakis asks, can we explain how sentiment analysis works in a nutshell? I'm not so sure. If you can do it in a nutshell, that's good, but it's done by training a model with examples which have a solution already. So it's very different approach. So I don't know if you want to go there. Otherwise, it's a great talk to place for another day.
Yeah, do you know what? It's because I have a little code that I did for sentiment before, but it's just I feel it's kind of the code is doing too much work, and I don't know enough about what it's doing. So for that very reason, I decided to leave it off. But it actually maybe at some point, if there was interest, I could come back with like a range of sentiment models, because as you said, there's a lot of that training using things like Amazon Mechanical Turk to have people reading individual documents and going, this is happy, this is sad. And it's like I don't know. There's a lot of ethical issues around the use of Amazon Mechanical Turk, paying people like tiny wages, well below. They're mainly American, and they're paid well below the American minimum wage. So there's a, but I think there's maybe more algorithmic bases for coming up with sentiment now, and so yeah, that'd be something that'd be interesting for the future.
Grant. What's this Java thing that ruined your ground design?
Yeah, it's what you can do topic modeling through GenSim just within the package, and it's you lose a few percent of coherence compared to this Java model. So the Java model was designed by historians in the University of Massachusetts, and it's famously good at LDA. So that's that was the reason I was using it. But do you know? You know what I will do, and I'll make a note to do this, is I have this exact same code without Java. It's just so just all contained within Python. So I'll edit the one on GitHub to include the code without having to mess with Java, because it's
Well,
I actually I have it in a different,
to use the best of every world, and if you can drive Java apps or Ruby apps or God knows apps through pipelines, and re-inject them in your main drive if Python is your thing. So there is no shame,
Well, it is very messy though. The internet, I'd say from my searching, the internet's discussion of this app of the Java app is I'd say about 100,000 people going, it's not working. What is Java? So yeah. It could be improved.
Yep, so Java is also answered. Brilliant. Wrong button. And R is the thing as well when you try to deal with that kind of problems. It would be one tool in the toolbox. Well, I know we have R aficionados here in the room.
Ah, okay.
So yeah, it's a great tool for statisticians. I admit that. So
it's grand. I'm starting to teach a statistics course in DCU this semester, and I've ditched OR and put in Python instead. Actually, just because I think it's a more beautiful language, and
okay, you get a sticker and a T-shirt now.
Thank you. Yes, yeah. But it just flows better. Why wouldn't the world have more Python? Really, that's the thing, really.
Okay, we'll get him socks as well, I think. I'm not ready. So brilliant. Yes, Connor has put in the chat, not in the questions, but is would you come back, if you don't mind, into the the calculation of the coherence score and what it entails on what it's based. It's always a bit difficult because there are theoretical math, and you have this number you have to figure out now with your guts what it means and how it should drive you. So the higher the better, but you said also above a threshold it becomes doubtful, and you've been overfitting.
Yes, yeah. There's a nice there is a nice OR package that looks at a few different coherence measures, but it's kind of, I mean, I think what people do is they just choose the one that has the highest coherence because it makes them look good. So I'm not sure. There's a few different ways of looking at it, but it's fundamentally a very old idea that it's that if somebody who was, say, an expert on cycling that knew everything about cycling was to look at these articles, would they go, that's it, that's what's inside my head? That's what the statistic is aiming to do. Now, how easy that is is a whole other thing. But it looks like it looks at, say, it's in essence it's a little bit like the k-means clustering in a way. It's like how far, how bubbles are a little bit away from each other, like in that pi LDA viz, that they're not overlapping too much, that there's that type of between topic distance. It's I think it might be something where I might need to include an article on GitHub rather than drag on the shady parts of my memory before I go into any more detail on it. But it's yeah, it's essentially that broad idea.
Cool.
Is that Connor? Yes, yeah. Perfect. I'll so for Connor and for anyone interested, I will include, because I read something that was very good about those different coherencies, but it's the type of thing you read it and you go, well, that was great, and then it's gone. But it was a very nice explanation of the different ways of understanding coherency.
Cool stuff. Yeah, reference a cheat sheet.
Yes, yeah. Who needs memory when we have cheat sheets, eh?
Last one. Okay, last one. Then we've closed the question. So many questions. That's a edgy subject. So Harek obviously has an idea behind this question. So would you recommend this kind of approach for 700 documents with an average of 14,000 words each?
So an average of 40,000.
Yeah. What's your standard deviation?
It's
you have one document with a gazillion word and all the other are empty. That's it.
Yeah, it'd be better. I think I can't imagine there can be, well, what they do with company annual reports, which might be around 40,000 words. The average corporate annual report might be around that. Is they pick out bits of it, and I think what you'd need is some way to coherently summarize the articles before you get into topic modeling. So there's things like that. Maybe you might extract all paragraphs that have a keyword in that document. So you might go, let's say it's cycling. Let's say there is a weird world out there where there's 740,000 word cycling articles. You would just extract all paragraphs that have cycle, cycling, bicycle, bike in it, and everything else gets chucked in the bin. The idea there is, it's like there's going to be a page of acknowledgements, for example, and that's going to in every article, in every 40,000 word document, and that's going to mess up the topic. So the more that you can bring it down, ensuring that only the bits included are kind of direct relevance to what you want to study. So I'd say there'd be quite a bit of pre-processing then that would help with the coherency. But the glory of topic modeling is you can just pop your data set in and see, do the topics make sense, and do you get good coherency scores? So there's no nobody's going to keep a record and judge you. You can do it all in private and see if it all makes sense. But I would say that finding a way to narrow it down would help a lot.
Cool. Yeah. Yep. Well, we have thanks now coming in. So yeah, I don't know. Raise your hand if you want to applaud, because that's the only way we can do it in this creepy world.
I'll take it.
So yeah, that's the online version of.
Yes. No, it's a pleasure.
Social acknowledgement. I think this was great. It has the nice smell of the real experience of typing, sweating, tweaking, and making it all over again. And it seems you have inspired a number of projects. So I hope they'll come back to report on their progress and what they've learned at that stage. Well,